My project is on whole slide image instant segmentation. So the problem is with pathology. These pathologists examine body tissues and they try to identify disease, but this can be prone to error and just slow. The solution is called digital pathology, which uses artificial intelligence to annotate whole slide images. This is much more accurate, more efficient, and quick. And this is what an annotated slide would look like. There's a 5 labeled on the left, and each color represents a class. So the dataset I use is called the Panoop dataset, which has over 20,000 slide images, which you can see on the bottom left labels the input. And total number of labels is 205,343, which is just the ground truth image, as you can see on the right. That's what the labels would look like. For pre-processing, I created 2 sets of images. So the first image is the normal RGB image that we got from the dataset, and the second is the hematoxylin intensified image in hopes of getting a more informative image to pass into the model. And I used 2 models, MaskRCNN, which is known as a mask region-based convolutional neural network, and a YOLO V7. Both these models just go through an image and try to label them as a certain class. Each pixel is a certain class. So I used the dice score to compare these different model results. And so the one with the highest was MaskRCNN with the RGB image with the dice score of 80.31, and the lowest was with the YOLO V7 with the hematoxylin intensified stains. So when we look at this graph, we can see that the dice scores are pretty close, but MaskRCNN with the RGB image does have the highest dice score. There are error bars on this graph. They're just really hard to see because the standard deviation is really low, which means that the models produce consistent results for each image. So I did do statistical testing. So I compared MaskRCNN with the RGB images and the YOLO V7 with the RGB images, and I got a p-value of which is much less than 0.001, which means there is statistical significance. And then I also compared the MaskRCNN with the hematoxylin images and YOLO V7 with the hematoxylin images. And I also got a p-value of much less than 0.001, which shows the data is significant, or the difference is significant. So with the conclusion, we noticed that the MaskRCNN model outperformed the YOLO V7 model in both image input sets, the hematoxylin images and their RGB images. So the engineering goal of this project was achieving a dice score of 85 or more, and it was not met, but the collected dice score is still high. For possible improvements, I could modify these models to take in different channel inputs, and I could make my own image with 6 channels, which is much more informative, and try to pass that into the model and see the dice score. And yeah, that's my project.